We are in section 6, hypothesis testing. The last time we met, we looked at the one sample hypothesis. And I gave you an assignment to have a look at and to submit. Today, we want to extend it to two sample hypotheses. Two sample hypotheses. Remember this T table. It is a table we used when we were talking about the one sample hypothesis for a sample size of less than 30. And then we also had a Z. And the Z, I demonstrated actually how to read the Z. So check the videos I posted and you see I step-by-step demonstrated how to find the critical value, how to find the test statistic, how to find the p-value, especially the p-value, how to find it using the Z. That one was a bit tricky, but we cracked it. Today, we want to look at two sample hypotheses. Okay. Now, the first step in hypothesis testing, if you can remember, is to formulate the null and the alternative hypothesis. So here's the thing about two sample hypotheses. You can have MSc students, and then you can have MBIA students. They are both learning statistics for business analytics. You can now get the scores of these two different samples. You check the scores. The scores are normally distributed. And you want to know whether there is a statistically significant difference between the mean scores across these two groups. That is across the MSc and the MBIA students. In other words, you want to know which student group are the smartest. Because this course is being taught to all of the two groups. MSc students are studying this very course. MBIA students are also studying this very course. At the end of the day, we get the overall exam score, we tally the mean, we check the mean, which is a typical average, a representative of the whole, and then we use that to determine whether the MSc student outsmart the MBIA student or the MBIA student are smarter than that. You can formulate a hypothesis that is a one-tail or a two-tail. The one-tail hypothesis always looks at greater than or equal to, greater than or less than in the alternative. In the alternative, you will have greater than. These are one sample. In other words, these are one directional or one-tail test. But in a two-tail test, the alternative hypothesis will take two directions. So the mean in the first group is different from the mean in the second group. That is two-tail. Which means that if you move this one to the left-hand side, you will have this something like this. In other words, the two means are not different from zero. But when you have the mean in the first group, the population mean in the first group is bigger than the population mean in the second group, that is a one-tail test. So learn how to formulate a hypothesis. Now, which one is the one and which one is the two? The one is the one that comes first in the sentence. The two is the one that comes second in the sentence. So the first step in the steps, the first of the four steps is to formulate a null and alternative hypothesis. And those are the different kinds of formulation that you have. Now, the next thing is to calculate the test statistic. And we are calculating the test statistics to check whether there is a significant difference in the mean. Now, there are two tests you got to use, either a Z or a T. We know we use a T when the sample size is small and the population is unknown. And that a Z is used when the population standard deviation is known. But you can even have a situation where the population standard deviation is not known, but the sample size is big. So you can use the sample mean to approximate the population mean, because the population mean is unknown. And then there is, so let's take them one by one. Okay? A situation where the population means in both situations, in both groups are known. If that is the case, this is the formula that for calculating the test statistic. Now, when you look at the test statistics very carefully, you will notice that inside the test statistic, okay, there is the population variance there. There's a variance. The variance from the first group and the variance from the second group. And the formula for calculating this variance is what you have on the right side. Okay. So that is when the population standard deviation is known. Now, when the population standard deviation is known and we are now in large samples, we are still going to use the Z. And in the process, when the population is known, when we have large samples, we are going to use the Z. And in using the Z, you got to also ensure that the sample size is bigger than 30 or equal to 30. But you can also use the sample standard deviation if you are not sure of the sample. I mean, if you don't know the population standard deviation. And then the last one is when the sample size is small. But there are two of them. The sample size is small, but then the variances are equal. And if the variances are equal, then you're going to use a pooled variance because the variances are equal, they're the same. So you use a pooled variance. The test statistic is calculated with this standard error here. And this standard error is what calculates the pooled variance. And so you're going to use this huge formula to calculate the pooled variance. But remember that when calculating the pooled variance, each standard deviation is needed. Each standard deviation is needed. And you have to use this formula to calculate the standard deviation. Then after you've gotten that, you substitute each one of them before you can get your final one. There are 4 of them, but sometimes they can be a little bit confusing. That's why I'm taking my time to put them. Then there is a last one. Remember, I said that the pooled variance, the sample size is small, but then the variances are equal. Now we have where the variances are not equal. Still, the sample size is small, but the variances are not equal. So watch unequal and equal variances. In the one where the variances are not equal, the test statistic is different from the one we looked at. Look at the one we looked at. The test statistics, the square root, inside the square root is 1 over the ni, the sum of each one. But then here, when they are unequal variances, the way you calculate this test statistic, there is no standard error or pooled variance. Okay, there's only standard deviation. And that's all. Everything else, you don't need to calculate that, but you need to calculate the degrees of freedom. And that degrees of freedom calculation is a little bit tedious. But once you get that, that is what you're going to use to find the critical value. But the actual calculation of the test statistic is simple. Understand that it doesn't assume equal variances. And that is what normally people use generally. That is also what the Excel software has been using generally. An example would do. Formulate a hypothesis, and always remember that when you formulate a hypothesis and it is a one-tail, then your reading will be a one-tail part of the table. If it is a two-tail, it will be a two-tail part of the table. So let's take an example. I want somebody to read a story for us. Who can read it? Okay, before we do that, let's see, I'll come back to you. Before we do that, let me just write some few things here to be sure that you're ready. Suppose I say that the mean score for MBA students in statistics is at least that of the mean score for MSc students in statistics. How would you write the null and alternative hypothesis? Let me write it here. Okay. The mean score for MBA students doing statistics is at least that of the mean score for MSc students in statistics. How do you formulate the null and the alternative hypothesis? Who can try? Pache?
So the null hypothesis will be HO colon mu is greater than or equal to mu1 is greater than or equal to mu2.
So in this case,
So
you gotta indicate what you mean by mu1.
so mu1 is the mean score of MBA, and
Okay.
mu2 is the mean score
So
of
we can also make it like mu MBA. Watch it.
okay
Uh-huh.
is greater than or equal to mu MSc.
Exactly, mu MSc. Uh-huh.
That's our now. Then our so we can further simplify it by sending the MSc to
Okay.
the other side.
Okay. Let's leave that one.
Okay. Then the alternative would be um, mu MBA is lesser than mu MS.
Mu MSc. Exactly. Excellent. Excellent. I'm giving you 3 marks for that because that is really good. Flash Papa, are you here? Can you please document that for me? Flash Papa, can you document that for me?
Yes, yes.
Yes, please, Doc. Yes, please, Doc.
Flash Papa, pay attention. Beg you. All right. So this is it. Now, let's explain this alternative hypothesis in practice. What does it mean? In practice, what does this alternative hypothesis actually imply? What you've just written, what does it mean in simple language? Given the preamble we've already said, what does it mean for a 7-year-old to understand? What does it mean? Mercy.
Please, I want to try with the null hypothesis.
No, I mean the alternative. That's all I'm asking.
Okay, it is what we test about the population.
Mm-hmm. Okay. Okay. You've tried. Let's go to Clement.
So please, in simple terms, it means
Clement, I can't hear you at all.
Please, in simple terms, it means the null hypothesis is false.
That's what you would have explained to a 7-year-old child.
Yes. So in simple
You would have
terms,
said that in simple terms, my 7-year-old boy, it means that the null hypothesis, that's what you would have said.
it means the mean score
Go
for
and think about what you go and think about what you say and come back again. And I want you to think before you actually, because I'm now helping you to think, and I want you to take a time and think. Eileen.
Yeah, I think it means we are just testing whether MBA students have lower mean score as compared to the MSc students in statistics.
Do you use the word just? I want a very simple, practical thing without complicating terminologies. I'm not getting it. You know, somebody is not really thinking like, a teacher. You're all thinking like students answering me. But I don't want you to think like a student answering me. I want you to think like a teacher explaining it to a 7-year-old child who does not understand mean, hypothesis, and all of those English. Those who have spoken, lower your hands. Let's go to Kwachi.
I was going to say it means the if we were to take it means the average or the score of the students in the MBA class is lesser. So that's the alternative. So it means the score of the MBA class is lesser than that of the MSc class. I don't know if
Right, but not. Let me take the last person, Andrew.
Okay, sir. I will say that the alternative is we are trying to test the alternative statement. That is the opposite statement.
The child doesn't understand this thing. All right, so this is what the child is likely to understand. We all know that these things are scores. So what this alternative hypothesis simply means is that the MSc students are smarter than the MBA students. That's what it means. Relatively speaking, that's what it means. Okay, MSc students outsmart or are smarter than, they outsmart the MBA students. Does that make sense? Or still, somebody doesn't. If you don't understand anything, I didn't explain it to you. Does that make sense?
Yes.
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 How does it make sense to you? Andrew, how does it make sense to you?
Okay, it makes sense to me in the sense that the initial statement, the now hypothesis says that the MBA students are at least, in terms of being smart, they are at least equal to MSc or smarter than MSc. But the alternative view is that the MSc outsmarts MBA students.
Because what? The MSc outsmart the MBA student because what? Because looking at the alternative, it tells you what? Anybody?
It tells me that the MSc are smarter than the MBA.
Oh, no, that one you are repeating yourself. I mean, looking at the things, it tells you what? Looking at the writing. Because I've turned that statement around, Pache.
I mean, since the scores of the MBA class is greater than, or at least greater than,
No,
sorry,
look at that one. Look at the alternative.
the down one. Okay,
Yeah.
that means since the scores of the MBA are less than the scores of the MSc, it means that the MSc students are smarter than the MBA students.
Exactly. This is the way you analyze things. We are talking about the average scores. And when you look at it, it's clear in the alternative that the MBA people, the average scores is tiny compared to that of the MSc, which means that the MScs are smarter, they are brainy, they are sharp. So whenever you are trying to interpret alternative or normal hypothesis, both null and alternative, don't use is greater than, is less than to talk. Don't use the English there, that statistical English. Speak of it in terms of practical relevance. Make it practical. Make it the language we talk, because everything, no matter how complex it is, can be simplified to a 7-year-old child. Albert Einstein, he said that if you can't explain it to a 7-year-old child, you don't understand. If you finish explaining it to a 7-year-old child, and 7-year-old child say, ah, and you do it again, and he say, ah, then you are not helping. So that is how, because you will get this in exam, you will be asked to interpret your point practically, very practical. All right, any question? Good. So now let's take an example, then have a dance to it. Somebody should read for us. Who will do? Yes, Miss.
Okay, so purchasing managers have noted that they order many of the same types of items from alum sheeting and durable products. It is believed that alum sheeting does not have a longer lead time than durable products. Yet, if its lead time is significantly longer than that of durable products, managers are considering dropping alum sheeting from their supplier base. Note that the time between the placement of an order and its arrival is commonly called the lead time. Test the hypothesis for supplier-led lead time performance. Should the purchasing managers drop alum sheeting? Formulate the hypothesis and the null hypothesis and the alternative hypothesis. Use both critical value and p-value approaches. Use alpha is equal to 1%.
All right. So these are some few other information. Which tests should be used? Are the variances known or unknown? And things like that. Guys, your MSc requires you to set up, okay? If you think you are not setting up, I'll beg you to set up. I will beg you to set up. The entire MSc requires you to set up. Whether you are working or you are not working, you have put some challenge on your life for the next 1 year. You've committed. You're committed. You are committed. It's like getting pregnant, and it's 6 months, and you said that no, I don't want to get pregnant again. No, you're committed. So once you're committed, you got to look after yourself till the baby is born. You got to make sure you go through the learning, the routine checkups. I beg you. I want to be sure that you are all paying serious attention to the your courses you are doing. So this is the data set. Okay. You have the supplier. So this organization that we are looking at, okay, they have a manager, and that is the purchasing manager. And you see, I'm trying to explain it to you, but ideally, if it was an exam situation, you got to understand it in total yourself. And you got to eat the content like you are the overall boss. You have the mental nuances. The language is clear in your head. So as a purchasing manager, you normally buy the same thing, from 2 companies, alum sheeting, durable product, alum sheeting, durable product. And the one that takes a shorter time is what you're looking for, because we define lead time as the time between the placement of the order and its arrival. So imagine you order something from Pizza Hut and you order something from KFC, and every time you ordered both of them at the same time, but KFC came after 30 minutes, Pizza Hut came after 1.5. And you consistently notice that is happening. What will you normally do? Anybody? Participate. What will you do? And you need this thing very quickly, usually. As time goes on, over time, what do customers eventually do? They stop. They stop buying from the one that is taking them longer time. That's the whole point. They stop buying. So lead time performance is very important. You got to be able to do things quickly. But here's the thing. The manager believes that alum sheeting doesn't have a longer lead time than the durable. That's what they believe. In other words, alum sheeting have got a shorter lead time, relatively speaking. But they don't know whether that is significantly true. They don't know whether this lead time alum sheeting have is significantly longer than that of the durable. They don't know. Why? Because they want to drop, they want to stop buying alum sheeting. And therefore, they need to check the time it takes. So look at some of the times it takes. It takes 6 minutes, or let's say 6 hours, to actually get the first order from alum sheeting. It takes 3 minutes to get the order from durable products. It takes 9 minutes to get a second item from alum sheeting. It takes 4 minutes to get a second item from durable product, and then on and on and on and on. First thing I want you guys to take note is that is a sample balanced or unbalanced? The sample. Is it balanced or unbalanced? And of course, you will explain what you mean by that. Is a sample balanced or the sample is unbalanced? Sylvia.
It's unbalanced.
Explain.
Because we are not using the same sample size.
Explain further. Explain further.
That's what I know.
Who polish it? Adam.
Yes. So as he said, we are not using the same sample size, and what we are trying to do is to find the average. So if we don't have the same sample size, we would have skewed results.
You're not using the same. I want to understand that.
Okay, so the lead time for the durable products, we have more information about that than the lead time for the alum sheeting. That's what I mean.
Explaining it further. Okay. But when I said to her explain further, she said that's what she can explain. But you should be able to explain things in multiple ways, because you understand. When you understand, there are several ways you can look at it. Okay, very good, Adam.
Yeah.
That's 2 marks again for you, Adam, for concentrating and pushing the frontiers every single time. That's your take note of it. So we're about to test the hypothesis as to whether something is something or that. How would you formulate the hypothesis? How would you formulate the hypothesis? And what word will be guiding your thought process in formulating the hypothesis? How would you formulate it? Millicent.
So the word that will be guiding
I want to ask you questions. Don't say that that's all I know, okay?
Okay.
Because what you're about to tell me is correct from your point of view. So when I ask you questions, then you should be able to defend that correctly. Please go ahead.
The word that's guiding is not longer done. So it says does not have a longer lead time than durable products. So for the null hypothesis, it will be H naught, our mu of the alum sheet is less than or equal to our mu of the durable product. And for the alternative hypothesis, it will be HA colon, our mu of the alum sheet is greater than our mu of the durable products.
Okay. Let me ask you a question to be sure you get it. So what is the first one trying to say?
The first one is saying that the lead time will not go beyond a certain number. So
My
it
lead
will either be
My lead time.
sorry,
My lead time.
say
Or
that
your
again.
lead time.
The alum sheet lead time
Now you're talking on. Okay.
will not go beyond a particular time frame.
No, that is not what it's saying.
It says it does not have a longer lead time.
That is not what it's saying. What is the first one trying really to say? Guys, your understanding of the hypothesis is more important to me than the hypothesis you write. Because you need that understanding to do your conclusion, which is normally 10 marks. So it's important you understand the hypothesis. Okay, let's go to another person who, Eileen.
So I think it's trying to say that the alum sheeting does not take a longer period as compared to the durable product. In other words, durable product takes longer than alum sheeting for the null hypothesis.
And so therefore,
we are concluding that alum sheeting takes less time as compared to durable products.
So as it is standing now, this manager wants to do what? Wants to buy from who? As it stands now, if the manager wants to buy, it buys from who? Is you the one, Millicent, who spoke? I'm asking. I want to be sure that you understood what you just told me.
Okay. So if we're going by alum sheet not having a longer lead time, if we're staying with the null hypothesis, then he should buy from the alum sheet, but he doesn't believe that, and so that's why we have the alternate.
Who spoke? Is it Millicent or?
Yes, Millicent.
Good. That's 2 marks for you. That's it. Okay. So if he should go by what the standard is saying, what the belief is in town, he will buy from alum sheet. But I like the last point you even added. Okay? But he doesn't really believe that that is the case because something has happened and he wants to test his own hypothesis. And this understanding must encapsulate your mind. So in your head, before you start a hypothesis, you know that there is a general belief that alum sheeting is good in terms of time performance. In terms of lead time performance, it's good. People want to buy, but he doesn't believe alum sheeting is good. He believes that maybe durable is good. But until you subject that to statistical torture, you cannot make the conclusion. So that is how you formulate the hypothesis. So let's go back to the formulation of the hypothesis properly. So the first one, you should always formulate in English before you go to the statistics. The first one is alum sheeting is good, so maintain it. Maintain alum sheeting is a one with the best lead time. The alternative is saying that drop it. Okay, that's what a guy is going for. Drop it because durable is better. So when you write it like this, you have a fuller understanding. And then, you can proceed with the rest. I didn't write a hypothesis mathematically. Oh, so sorry, but I think what she said is the case. So it's supposed to be the H naught will be mu alum sheeting less than or equal to mu durable product. And that alternative will be H naught, HA colon mu alum sheeting greater than mu durable product. Okay. So when you formulate it like that, in case somebody doesn't understand what we are doing, let me write it, because this thing, if you don't write it, somebody will say that he doesn't understand. So the null hypothesis will be mu. Normally your mu1 will be alum sheeting, so you can still use mu1. I only like to sometimes make it practical. Alum sheeting less than or equal to mu durable product. Okay. And then the alternative will be mu alum sheeting greater than mu durable product. And what they mean is what is above. Is this a one-tail or a two-tail? Is this a one-tail or a two-tail? This is a very simple question. So let's crack it. Make sense?
It's one tail.
It's one tail. We know this, we know this very, very fully. Now, we have been able to establish that this is a one tail, and we will use that idea when it comes to the conclusion. Now, what is the alpha level for this? What is the alpha that you were given?
1%.
What is the value of alpha? Raise your hand and tell me. I'm not going back to the question, but I know you all remember it. Somebody at least remembers it. Messi.
1%.
1%. So that is 0.01. You keep that also in mind. Okay. Now, what is the first thing you got to do when you're doing a two-sample hypothesis of this nature? The first thing to do is to determine whether you're going to use a z-test or you're going to use a t-test for this. Which one are you using? Looking at the scenario, at which one is it sensible without looking anywhere, without being influenced by anything but just your thought process. Which should we use and why? Kwache?
I think we should use a T statistic, a T test, because from the looks of things, our sample is less than 30.
Very good.
Our sample size is less than 30, yes.
Very good. And then also what? That is good. And then also what? Not you. I'm asking somebody else. Apart from the fact that the sample size is less than 30, there is also why are you using this? It's clear from the earlier.
My network is down, so I can hardly.
Okay, don't worry. I wasn't asking you. I was asking everybody. Ivy.
Okay.
The population is unknown.
Excellent. No, the population is unknown. Be clear. Be clear. I almost gave it to you. It's not just the population is unknown. Be clear there. Ivy, come back again. I don't want somebody to take your marks. No.
Is there a pooled?
No. Let me go to Marilyn.
So please, the population standard deviation is not known.
That is it. 2 marks for that. It is a population, Marilyn, that's 2 marks. It is a population standard deviation that is unknown. Okay. And therefore, we got to use a T. Now, I told you also that there are 2 T's, the equal variance and the unequal variance. Let me just go back here to remind you of something. So this is an equal variance, okay? And then this is a formula for finding the T for the equal variance. And this is a Welsh one, the unequal variance, also T. Which of these 2 are we likely? I'm saying likely because you haven't mastered it yet. But which of these 2 are we likely to use? Which of them? Equal or unequal? Again, coming from your own thought process. Oh. You don't know. Okay. I thought this was going to be. So that is the unequal variance. Why? Because the sample size is unbalanced. That is the first step. The sample size is unbalanced. You remember one of you explained that is unbalanced, and I told a person to explain why it is unbalanced. Okay. And that is it. Now, even though the subjects are separate, the sample size itself can be balanced. Okay. But in this very example, the sample size are different. There is a smaller sample size in the alum sheeting than there is in the what do you call it? In the durable product. Okay. So now the formula that we are going to be dealing with throughout is this unequal variance formula. That means that the test statistics that we are going to be using is going to be this T. And when you look at the test statistic, it means that we need to find the X bar in each case. It also means that we need to know the sample size in each case. And we also need to know the sample standard deviation in each case. Of course, the sample standard deviation is just the square root of the sample variance. Okay. Once we have these elements, we can calculate anything on the screen. So let's take them one by one. Okay. So first, we need to find the sample size. What is the sample size in the alum sheeting? What is the value of the sample size? Or how do you find it? Anybody? Just tell me how you go about finding it. Even if you don't know the exact value, at least you know how to go about finding the sample size in the alum sheeting. And that's of the durable product. Yes, Patrick. Patrick, you're really
Okay,
participating.
let me try. I think we just count the number of let's say entries we have. So like the alum sheeting, the lead time, for instance, we count how many of them that they are, since they've even done it in a table for us. So from here, it's 1, 2, 3, 4, 5, 6, 7, 8. So the sample for alum sheeting will be 8. I don't know if that's it.
And then
we also do the same for the durable products, where we count each of them.
very good. Very good.
Yeah.
Excellent. That's it. That's how you do the counting. Okay. That's a 1 mark work. Just calculate all your marks you get in, because if the class rep forgets, you remind you. So the sample size is 8 when you count it from the alum sheeting. And then when you count it from the durable product, the sample size will be 18. You would have to calculate this yourself, for example, in an exam. Okay. And this one is easy. This one, picking the sample size is easy. The next thing you got to do after finding the sample size is to find the mean, the sample mean. Now, how will you go about finding the mean? I just want to know how you will show me. How do you go about finding the mean? You can show me the steps. Samuel.
No, you get the mean by, for instance, for alum sheets, you sum up all the lead time, then you divide it by the number of the lead time, we get it the 8. So when you sum up of 6, 9 plus 7, 7 plus 5 plus 7 plus 9 plus 6, we get 56. So 56 divided by the number of lead time is 8. So
Right.
56 divided by 8, we get 7.
And then continue. And then
so the mean for the alum sheet is equal to the 7.
good. And then
then when you come to the durable products,
we do the
you
same.
follow the same the same process.
Exactly.
So the summation for the lead time will be 64. Then
you calculated all of them right now.
The number.
Have you calculated all of them now, Opele? Sammy?
My network. Doc.
I was asking if you have calculated all of them right now.
Yes, please. Yes, please.
So you have calculated there calculating. That's good. That's good. So what did you get? You got something like 4.923. Is that it?
Yes, Doc. Yes, Doc.
Very good. 2 marks. So that is how you got to execute the sample means. Okay. Now that is these two are the easy part. The next part is calculating the standard deviation. But watch this. To be able to calculate the standard deviation, you got to use this formula for each one. You can see that the standard deviation, I've put I there. The I means that you are doing it for group 1. So if you are doing it for group 1, I becomes 1. If you are doing it for group 2, I becomes 2. Group 1 is alum sheeting. Group 2 is durable product. So you're going to take for group 1 and calculate. Now this is it's not hard, but it's just annoying. But you must have the patience of Job to do it. So the first thing you will do is that you will pick each of the numbers and subtract the mean from it. So as an example, in group 1, the mean is 7. So you're going to take 6 minus 7 plus 9 minus 7 plus 7 minus 7 plus 7 minus 7 plus 5 minus 7 plus 7 minus 7 plus 9 minus 7 plus, okay. But you can see that some of the numbers are 0, I mean, some of the numbers are 3, some of them are 2 and all of that. So they can help you because you just have to see the common ones. And then once you do it, let's say you do 6 and 6 appears 5 times. Okay, so you do 6 minus 7, that will give you -1. Then you multiply it by the 5, that will give you -5. So you can have an easy way to do that. Very good. So this is how you do the first one. Okay, you calculate that, and remember, it is the sample size -1. So when you do this, you divide it, do for each one. Oh, there's a square. It's not in the formula. Okay? Why it is not in the formula, I don't know why, but there's supposed to be a square. Just go back to the formula here. Yeah, I made a typo here. Watch this. Oh. Is that? Okay, I was calculating the variance. Okay, so you get this. You square them to clear the minuses. Okay, and then that will give you a sample standard deviation of 14/7, which eventually will give you 2. Then you do the same thing for the durable product. Okay, in fact, you can take the standard deviation as well. The square root of 2 will give you a standard deviation of, because this will give you the variance. Okay, so you have a standard deviation of 1.414. You do the same thing for the second one. Now, in the second one, check it. There are similarities. You have 3 appearing once, okay? And then look at 5. 5 appear 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 is appearing 9 times, okay? And look at 4. You have that. So for some of the numbers, we just have to do, because they are repeated, we just have to do for one of them. So it becomes very easy, like I indicated. So if you take, for example, look at the mean. I decided to use the 13, okay, and then square it. But of course, you can also use the original one, which is 4.923. Just that I will give you a lot of decimals. So you do each one of them. Remember that the first one, okay, appears only once. Okay. The first one appears only once. The second one appears once, the third 9, then 2. Okay, so you substitute that. You can do any of them. Sylvia, your hand is up.
So please, can you explain why you are squaring it again? Because I still don't understand.
Why I am squaring?
Yes.
I'm squaring because I'm calculating the variance before I calculate the standard deviation. That's why. I'm calculating the variance before I'm calculating. In fact, this thing should be the variance. Sorry, it should be the standard deviation. Okay. This thing should be the standard deviation. What I'm saying is that the one on the right is a standard deviation. But I should actually do the variance first. So I've actually written the variance whilst calculating the standard deviation. So,
okay.
So you got to square them to make it the variance to also clear the negativity.
Okay.
But what I've decided to do is that what I've done for the second one, you can do it any way you like. You can just use the 4.9, but I just wanted to do some cancellation. But if you use that, my approach, it might be a little bit slightly confusing because I'm just seeing that 3 appears only once, okay? 4 appears only once, okay? And look at 5. 5 appears 9 times. Okay, so that's this one. And then I'm using that approach to do, and then 6 appears only twice. So I'm using that approach to do the calculation. If you use that, you're going to get something like this. The top part is going to be, because I have a 13, which is using this mean, okay? And then you can divide it by the 13. Remember, when you have this 13 and you multiply all of the 13 together, you are going to get these numbers. And then you divide it by the 12, which is the 13 minus 1. So the numerator is going to be this by that, all divided by this, and then you're going to get an average of 0.577. You can do this yourself by just taking the 4.9. So you can just take the 4.9 for each one. You can say that 3 minus 4.923 squared. Then the next one is 4 minus 4.923, and I keep going. You get the same thing as this. Very good. So now you have the two standard deviation. One is 1.414. The other is 0.577. Okay, you now have all the elements necessary to calculate the test statistic. So let's go to how do you now find the test statistic. So this is a second one. This gives you the variance, but the standard deviation is a square root of this variance, which is 0.759. You take these two, you remember the formula for the t-statistic. This is a formula. Watch it carefully. It says that take the mean of the first one minus the mean of the second one. Now, there was also the population mean, but the population mean is expected to be 0. So that's why I've not written that. You divide it by the square root of the standard deviation. Sorry, this one is the variance, take note, over the sample size in group 1. Then the variance in group 2 over the sample size in group 2. And then when you finish, you square root the denominator. So you substitute first. This is a substitution. Okay, remember that the mean for the first group was 7. The mean for the second group was 4.923. Okay, the variance for the first group was 2. The variance for the second group was 0.577. Let me just go back so that you are not confused and you understand. So we are taking these variances. The variance for the first group was 2. The variance for the second group was that. Sometimes you are using the variance to calculate something, but sometimes you are using the standard deviation as well. That's why you calculate both. All right. So for this t-statistic part, you are using the variances. And then each one divided by the sample size. Once you manipulate and calculate this, you get the numerator to be 2.007. And then you divide it by, this, eventually you're going to get the t-statistic, which is 3.83. Correct to 2 decimal place. 3.83. Now you have gotten your t-statistic. What do you do? The next step is to find the critical value. But the critical value, you cannot find it unless you have the degrees of freedom. Why? Because watch this. The critical value is given by this. T subscript alpha and then degrees of freedom. Or T degrees of freedom alpha. So you need the degrees of freedom and you need the alpha. Now you must have the patience of Job if you want to find the degrees of freedom, because you need this formula. But this formula is not that difficult because you have all the elements. Okay, so look at it. You have the variance. In fact, the same thing you have here, that is what you have here. But you're not taking the square root, you're taking the square. And then you take them in separately and you square them separately. And then you divide each one by the sample size minus 1. So you substitute all of the values. If you work it step by step carefully, oh, you wouldn't have. So this is where patience is needed. You just have to respect your calculator. And it's nice to be using 4 decimal places all through. And then your final answer, you give 2 decimal places. If you're working this in an exam, you'll be told exactly which decimal place to use. So once you do the division, subtraction, addition, multiplication, you're going to get the degrees of freedom to be what? 9.53, which is approximately 10 or approximately 9, depending on where you're coming from. Okay. And it's approximately 10, but somebody can say it's approximately 9. And you will see why I am trying to round it up. You see that very soon. So now that you have your degrees of freedom, go and check your alpha. So we're going to go to the T table and see what it will give us. I told you that it can be what, 9 or 10. So let's go to our T table. So this is our T table. You're going to look for degrees of freedom. Remember, we got a degrees of freedom of what? 9.5. So I'm going to use both 9 and 10. It will give you the same conclusion. So this is degrees of freedom of 9. And the one below it is degrees of freedom of 10. We are using alpha, which is how many percent? Who can remind us? We're using 1%. And which tail are we using? One tail or two tail?
One tail.
Go to the one tail here and start looking for 1% or 0.01. And that is it here. That is one tail, 0.01. So you're going to look for that and match that against 9. Match that against 9. Okay. And that will give you 2.821. Or if we were to use the 10, 2.764. Either of them is less than 3, 2.821. So if a student uses 2.821, it's fine. If another uses 2.764, it's fine. Because it's either 9 or 10. The decimals calculation will bring it to that value. That is why. In fact, even if a person gets 8, the decimals is what brought about that. So it's acceptable. Okay. So now we know that our critical value is going to be what? 2.821 or 2.746. Now watch this. Watch this. So once you've gotten that, you can now see that when you trace it, you get 2.821. Okay. And I've also indicated you can use the degrees of freedom of 10, and that will give you 2.716 or so. Either way, the test statistic of 3.826 is bigger than this 2.8 or 2.7. Okay. So now, that we know. We've used that. That is known as a critical value approach. And let's go to the p-value. You're going to also find the p-value and compare it with the alpha. The same way we found the critical value, the test statistic, and compared it to the alpha. So the critical value approach will use T test statistic, okay? And then it will compare it with the T critical value. And then you will also find the p-value and then compare it with alpha. They should all lead to the same conclusion. So let's see how to find the p-value. If you can remember one tail, we indicated that, and you want to write it down. Because it's not all the time you're going to play the video and remember. You got to sometimes write your own notes. It's faster. You always use the test statistic to find the p-value. That's it. Manually, you use a test statistic to find the p-value. What is our test statistic? Who can remind us? What was our test statistic? What was the value? I know it's behind us, but I know. So who can tell us the value? What value did we have? 3 point. Are you here?
826.
Good. So 3.83 approximately. Okay, but we are looking for 3.826. So you do 3.82. But then 2 decimal place is 3. So we are going to go to the table and then we are going to dump it into the T table. So watch how I go around it. This is very important though. Very important because you do the same thing. You have all of these tables given to you in the exam condition. So look at the table. This is a T table. We are going to look for 3.83. So we're going to search this entire swimming pool here. Okay. And then look for 3.83, the number closest to it. 3.83. Which number or numbers are closest to 3.83? Do you see what I see? So that's somewhere here, isn't it?
Yeah, 3.81.
Good. So you're going to get this something like this, 3.181. 81 or 85. Normally, when the numbers are too close, they are one above the other. They are vertically close. They are not horizontally close. So the good thing is that they are always supposed to be vertically close. So when you see it like this, you just climb up, looking for the p-value, because the p-values are these ones. So you're going to select a p-value, remembering the tail you had. Remember the tail. Don't forget the tail. Then you pick the p-value. So what would be the p-value? Anybody? What would be the p-value?
0.
Approximately 0. Okay. Approximately 0. But technically, there was a number there. This very table is not, if you check the actual table I sent you, it has all the full numbers. This one has truncated, cut off some of the numbers. So you see that it's 0.00006 or something. But basically, it's generally 0. It's generally 0. So once you got that, it's generally 0. You can read it. I've set it as here. So when you read it, you're going to get p-value of 0.0006, which is generally 0. Okay. And this is now compared to the alpha of 1%. And you can see that the error, the p-value is the actual error. So the actual error you made is way smaller than the expected error, which is alpha. So it means that you didn't make that much error, which means you must have high confidence level. So again, the test statistic is greater than the critical value. Let me tell you when to reject the null hypothesis. When do you reject the null hypothesis? You reject the null hypothesis whenever the test statistic is greater than the critical value or the p-value is less than alpha. That is when you reject the null. Okay. You reject the null. Should I write it down for you? Reject the null hypothesis if the test statistic is greater than or equal to the critical value, or the p-value is less than or equal to the alpha. That's it. Write it down. Write it down. This is when you reject the null hypothesis. So in our case, are we going to reject the null hypothesis or we are not going to reject? Anybody? Are we rejecting the null or not?
We are rejecting it.
Exactly. We are rejecting the null hypothesis. What is our conclusion? Remember what the null said? The null says that alum sheeting is what? Is less than or equal to durable. In other words, alum sheeting. Who remembers the null? Alum sheeting.
The lead time.
Yes. Alum
sheeting's lead time is less than or equal to.
Yes. So the null is saying that alum sheeting lead time is better.
Yes.
More or less. The alternative is saying that no. You want to reject it. And now you are rejecting what the null is saying. So you're actually concluding that what? Based on this research, you are concluding that what? You see, this is where the practicality of the hypothesis you spoke about comes in. Yes, Kwachi.
So the conclusion is to drop the alum sheeting for the durable products, since we have now found out that the durable products have a better lead time.
That's it. And look at the way you got to write. You got to use both the t statistic, the empirical value approach, and the p-value. So you have to write something like, since the test statistic exceeds the critical value, or the p-value is less than the alpha, you reject the null hypothesis. And conclude that at the 1% level, alum sheeting has a significantly longer average lead time than durable product. And that's exactly what Pache said. Okay, Pache, another one mark for you there. Okay. That What should the manager do? Kwachi has already done it. He said that we should drop it. Should drop alum sheeting. So the buying managers should consider dropping alum sheeting from their supply base. So you see here, you subjected this, but ladies and gentlemen, something has led to all of these results. Why is it that, we are saying that alum sheeting has got, should be dropped? Part of the reason for this work might be because we have a smaller sample size. Maybe if the sample size for both were bigger than 30, would have gotten a better perspective of the matter. But as it stands, looking at the data alone, alum sheeting has to go. Alum sheeting has to go. This conclusion alone is 10 marks, and it's very important. You see, that latter part of what should the manager do, that is more powerful than the decision. The decision is the one at the top. That practical conclusion is what the manager should do. And you want to always get that. You can do this in Excel, actually. You can do it in Excel. Maybe, just maybe, we can try this in Excel. So let me see if I can go back to the data set and show, or you can do it yourself. I mean, I've done it here, so you can easily do it yourself. But hey, let me just give you a feel of something. That might help. Should I do it, or you can easily do it? Of course, I won't ask you in an exam.
Sir, please do it.
I should show you.
Yes, please do.
But you're rather going to show me. No, normally when I give it to you and you are showing me, it's rather nice. It makes me happy that you are showing me. Anyway, so let's do it together. Let's go for an Excel sheet. Let's share an empty Excel sheet. And you can be doing it along with me because you have the data. You have the data, so I'm going to use the same data. But I'm actually copying from the PowerPoint and then using the same data. So I'm going to copy this thing and dump it in this here. So you see what I've done. Let me just all of this. Let me make it bigger, bigger, bigger. So you have the data sets all beautifully organized here. So what is the first thing that you got to do when you are dealing with this? You are about to do this thing in Excel. Okay. So the first thing you want to do is look for data analysis at the top. Click on the data tab, and on the far right, look for data analysis. Look for data analysis. If you don't have data analysis, let me know. But generally, you should have data analysis. But if you don't have, you will always have to go to file here. You click on the file, you click on account options, a pop-up will come. Okay. It's known as Excel parameter dialog box. It will come at the far left bottom. You choose add-ins. And then you will select analysis 2-pack. Now, in my case, analysis 2-pack is at active application. In your case, if it's not there, it means it's at inactive application. So you will click on it at the inactive application and then come down under the manager and click go. Okay. The add-ins parameter dialog box will show, and then you will check analysis 2-pack box. There's a box on the left, you check it, and then you click OK. The moment you click OK, the analysis, data analysis that is not shown on the top right here will start showing. Okay. Then you click on it. Now, when you click on it, you're looking for t-test, 2 sample. Okay, and you're looking for unequal variance. So you have to go down, scroll down, scroll down, scroll down, scroll down, scroll down, scroll down. Okay, you're looking for unequal variance. That is it. Unequal variance. Then you double click. Okay, to open that. Now it gives you variable 1 range and variable 2 range. But as it stands, you are wonderful to even know what we are going to do. So you're going to select all the elements of variable 1 range. Okay. So you select these numbers. Okay. I will pick them from here. So let me just delete whatever is here. We just click the first number, 6, and drag it all the way to the last one. Okay. If you want the headings, you put the headings on top of them. But you see here, it says labels. I didn't have the label, so I want to just delete it and rename it. So let's rename this as alum sheeting. Okay. Just use the labels, alum sheeting. I just want to put it there. And then label this one as what? VAT, durable product. But I can even kill whatever is here. I can kill this Excel sheet so that, delete it. So that everything just is nicely organized like that. Very good. So let me click on data analysis again. Okay. To sample. And then you would now highlight everything on the alum sheeting, including the headings. Then you come and click on variable range 2. That one too, you click everything, including, let me start again. You click everything and drag it all the way, including the heading. Okay. Then the hypothesized mean difference. Remember, the mean difference is always 0. So we normally can easily choose 0. Then the labels, you click labels. When you click labels, it means that you are recognizing that the labels have also been selected. Then under the alpha, the default is 5%, but we chose an alpha of 1%. So you click on 1% and change the 5% to 0.01. Then the output range, you can use output range, or you can tell Excel to create a new sheet for the result. So let's rather use a new sheet. So the result will come in a new sheet here. And click OK. You see, a new sheet 2 has been created, and the result is beautifully shown there. You are going to see that most of the results are similar to ours. Not exactly the same, but very similar. Okay. So let's first look at the mean. The mean is 7. The same thing as we had for the alum sheeting. The mean for the durable is 4.923. The same thing that we had. The variance is 2. The same thing we had. The standard deviation is 0.7577. The same thing we had. The degrees of freedom is 10. Okay. We had 9 and also 10. I said we can use 9 or 10. Okay. So the exact actually is this one. The manual is a table, so obviously there's some discrepancies. Then the test statistic, if you can remember, we had 3.828. And it's the same thing here. We rounded it to 3.83. That's the same test statistic that you are seeing here. And then one tail. Remember the one tail p-value? We had 0.0005. Okay, it's a similar thing here. Okay. And then the critical value, if you can remember, when we read the critical value for the one tail, do you remember the value we had? We had 2.8 something and 2.7 something. Do you remember? When we're using the 9, we had 8 something. And then when we're using the 10, we had 2.7 something. Well, because he is using the 10 here, that is why he's getting the 2.7 something there. If we were doing two-tail, we would have gotten these values. And once you have this, you are ready to go. So this shows clearly everything that we did in the manual calculation. Any question on this? Any question? Good. Now let's go back to the slide. So in the slide, the conclusion, everything, that is exactly. This Excel, I've also put it here for you. Okay? You can just go through to have a feel of all of these things. Okay. Now, this sample is independent. What we did is independent, which means they are separate subjects. Write it down. Independent sample is a sample where the subjects are separate. They are different. But you can have a situation where the subjects are the same. For example, a before and after test. A before and after test. For example, you can take the MBA students, you can record their exam in statistics in week 6, and then do another exam for them in week 12. The same people. You want to check whether there's a significant difference in the two scores, but the subjects are the same. That is known as dependent sample. The subject is the same person, but the samples are different. When you have that kind of dependent sample, the way you calculate the test statistic is different, but everything is similar. The hypothesis is the same thing here. But look at the test statistic. The test statistic is rather this. So you have a D representing the difference. And the difference is basically calculated as each of the before number minus the after number. So before number minus after number. Okay. So in our own, and by the way, the samples must be matched. Okay. So if you have sample A and sample B, if A is maybe 2, 4, 9, A is 3, 8, 1. Okay. They are all 3 samples, they are matched. Then the difference will be 2 minus 3. That will give you difference for the first observation. So that is -1. The next one, the difference is 4 minus 8. That will be -4. Then the last one will be +8. So that is what you do to calculate this difference, okay, DI. Then what do? Once you calculated the differences, you now you sum them, or basically you find the mean. Okay, you find the mean, and that will give you this D that you have here. Okay, then you create 3 columns because you are going to find the standard deviation here. You see, if you look at the test statistics, there is a sample standard deviation of the differences here. Now that one, to do that, you need a column for, you see how this formula is. You need a column for the DI. You need a column for the D minus the D, the DI minus the D, which is the mean. Okay. And then, so this one should be bar. There should be a bar here. Then you need a third column, which is D minus the D bar all squared. Okay, which is this. So you go and pick each of these D. The first thing is that you take this one minus the mean. Each one minus the mean. Each one minus the mean. Then that will give you the D minus the D bar here. And then finally, you square it. And after squaring it, you sum it. And then you divide it by the sample size. If the sample size, this sample size is 10, and this one, this sample size is 10, then it means that you're going to divide it by the sample size of 10 because that's for 1. Okay. And that's it. Once you find that, that will give you this SD. You come and substitute it here. That will give you the test statistic. That's it. What about the critical value? Well, the critical value is found the same way as the one that we did, the same way. Okay? If it is a 1 tail, it's the same thing like this. If it is a 2 tail, if the table is good enough to give you the value, the table actually pinpoints the critical value. And like I said before, you always have to use the test statistic to find the p-value. So if you had a test statistics to be 4.1, that's why you're going to dump it into the swimming pool to find it. So this is a paired sample testing. That is dependent. The one we did before was independent. So I've given you group assignments, and you're going to be doing this in groups and submit it. The first group assignment, you have to know which one you are using. This is group assignment 1, and you can see the samples here are unbalanced. You're looking at the salaries of UG lecturers and then KNUST lecturers. And this sample will tell you, you have to check whether there's a statistically enough evidence to say that the UG lecturers are earning more money than the KNUST lectures. The second one is our average annual cost of tuition. So again, you have public universities here. But watch this carefully. This one, you have to provide a summary statistics of the data for each university. You have public and private. Formulate and present the rationale for a hypothesis to compare the differences between the two. Okay. First, you have to determine whether it's a dependent or independent sample yourself. Analyze the data to hypothesize. Find the critical value, find the p-value. What is a statistical test of significance? And then what is your recommendation for GTech when it comes to annual cost of universities? So you have to do that and submit it also as a group. And then this last one is the Ginger board. Okay, so I've given you the HSB2 data set. Now, I've put a data set also in your group, so you should know it. And you have to take that data set. Let me just see if I can have a feel of that data set for you. Because I have it here. See, the more you work these things, the more it makes you understand this than if you're not working. So let me show you the data set. So this is the data set. So this data set is a data set of some students. In fact, the description is at the Excel bottom here sheet. It will tell you everything about the data set. The file contains 200 observations of some senior high students. And then you have their race. Some of them are white, some are African American, some are Hispanic and all that. Their socioeconomic status is there. The type of the school they are attending, whether it's a public or private school, the program they are doing, whether it's general, vocational, or academic, their reading score, writing score, mathematics score, science score, social studies score. Okay. Now, let's go to the question. Okay. What is this question really asking you to do? So you come here and say, does the writing score, so you have to use Python to guide you. Does the writing score differ across sex type? Now, because this data is plenty, you can't use hand calculation because we are talking about 200. So does the writing score differ significantly across the sex type? Now, remember that we have female and male. Okay. Specifically, do males outperform female? You do your analysis, put all your codes and everything. Is there a statistically significant difference statistically difference between mathematics and science scores? Okay, between males, that's how it's supposed to be. Statistically significant difference between mathematics and science scores. When it comes to males, okay, so when you take males alone, among the males alone, is there a significant difference between the science and math scores? We are not talking about females, it's just males. So that's a bit of a tricky thing you should look at. Then, do students from private schools perform better than those in public school when it comes to reading score? Okay. Reading score. So again, you're taking reading score, and then you are, that's easy. That's just like the A. Is a B you need to just check out. That's it. That's it, ladies and gentlemen. That brings us to the end of the entire caboodle. What a time.